Train is lifting a load of 1250 kg vertically at a constant speed of v meters per second. Given that the power of the crane is a constant 20,000 watts, find the value of v. So since we're talking about power, we know that power is equals to the forward force or the driving force multiplied by the velocity. And the other essential information that they've given us is that it is lifting a load at a constant speed. So constant speed means that there is no change in the speed, hence the acceleration is 0. And we can use the forces formula to find out the driving force, also known as the forward force. So the forward force is unknown minus the resistive force. So since it is moving the load vertically, which means that the downward force or the resistive force will be the weight of the load. So the mass is 1250, which means that the weight will be 1250 times 10. So it's 12,500 is equals to mass multiplied by the acceleration. So this side becomes 0 since acceleration is 0. Hence the forward force is 12,500. Now we have the value of the forward force, and we can use this and the formula for power to find out V. So we know power is 20,000 and the forward force is, or the driving force is 12,500 multiplied by the velocity. Hence V is equals to 20,000 divided by 12,500, which is 1.6. Hence we have the value of V, or the speed. Question number 2. The total mass of a cyclist and her bicycle is 75 kg. The cyclist ascends a straight hill of length 0.7 kilometers, inclined at 1.5 degrees to the horizontal. Her speed at the bottom of the hill is 10 meters per second, and at the top it is 5 meters per second. There is a resistance to motion, and the work done against the resistance as the cyclist ascends the hill is 2000 joules. The cyclist exerts a constant force of magnitude F Newton in the direction of motion. Find F. So basically in this question, F is the driving force exerted by the cyclist by his bicycle. So there are two ways to do this. We can either use the work power energy formula, or we can also find out the value of F using the forces formula. Since they've already given us the work done against the resistive force, which is part of the formula, I will use the work power energy formula, which is work done driving force is equals to the change in kinetic energy plus the change in potential energy plus the work done against the resistive force. So in the question, they've already given us the work done against resistive force as 2000 joules, and they've also given us the initial speed as well as the final speed, so we can find out the change in kinetic energy. And they've also given us the distance traveled, which is 0.7 kilometers. But if we notice that the speeds are given us as meters per second, which means that the distance traveled must also be in meters. So this is 700 meters. Now we also know that work done by the driving force is the distance traveled, which is 700 kilometers multiplied by the driving force. So which means that if we find out the change in kinetic energy and the change in potential energy, we can find out the driving force. So first let's find the change in kinetic energy. An easy formula is half multiplied by the mass, which is 75, multiplied by the final speed, which is 5 meters per second square, minus the initial speed, which is 10 squared. So this is negative 2812.5. And then we need to find out the change in potential energy. For this we will need to use trigonometry rules. So let's assume the cyclist ascends a straight hill of length 0.7 kilometers. So let's assume this is the hill, and it is inclined at 1.5 degrees. Now, so this is 700 meters, and it starts from the bottom of the hill. This means that this is height 1, which is 0. So this whole side must be equal to the second height. So we can use the sine function. So sine 1.5 must be equals to the perpendicular over the hypotenuse, which is 700. So sine 1.5 multiplied by 700. So change in height is 18.32. So this whole side is 18.32. Now we're going to substitute these values in this formula. So work done by the driving force is the driving force multiplied by the distance traveled is equal to the change in kinetic energy, which is negative 2812.5, plus the change in potential energy, which is the mass multiplied by 10 multiplied by 18.32. Because there is an increase in height, so this will be positive, plus the work done against resistive force, which is 2000. So this side is equals to negative 2812.5 plus 75 times 10 into plus 2000. And when we divide it by 700, we get the driving force, which is 18.46. So let's round it off to 18.5. And now let's give the final answer as a statement. So hence F is equals to 18.5 Newton. Question number 3. So a block of mass 3 kg is at rest on a rough plane inclined at 60 degrees to the horizontal. A force of magnitude 15 Newton acting up a line of greatest slope of the plane is just sufficient to prevent the block from sliding down the plane. Find the coefficient of friction between the block and the plane. So first let's analyze information that they've given us. First is that the mass is 3 kg and it is at rest, so initial speed is 0. And it is on a rough plane, which means there is friction. And let's make a diagram. So it is inclined at 60 degrees to the horizontal, which is this. So let's assume this is the block, and so there will be a downward force of the weight which we can resolve. So this is 60 degrees because this is 60 degrees. And this will be 30 cos 60, and this will be 30 sin 60, and this will be the normal reaction acting perpendicular to the plane. And then we also have a force of magnitude 15 Newton acting up a line of greatest slope. So this is the 15 Newton force pulling it upward. So they've told us that the 15 Newton force is preventing the block from sliding downwards, which means the natural direction of the movement is downwards, which means the friction will be acting in the opposite direction, which means it will be acting with the 15 Newton force. And since we know that the block is not moving, acceleration is 0. So first we're going to use the force formula, which is forward force minus resistive force is equals to ma. From this we can find out the value of friction, and then we can use that value of friction and the value of the normal reaction to find out the coefficient of friction. So in this scenario, the 15 Newton force and the force of friction is trying to move the block upwards. So we will take that as the forward force. So 15 plus the friction, but the horizontal component of the weight is pulling it downwards in this direction. That is the resistive force. And since acceleration is 0, this side will automatically become 0. So friction must equals to 30 sine 60 minus 15. Which is 10.98. And we know that friction is equals to the coefficient of friction multiplied by the normal reaction. And from the diagram we can tell that since it is in equilibrium vertically, the normal reaction is equals to 30 cos 60. Since this is acting downwards in this vertically and this is acting upward vertically. So 10.98 is equal to coefficient of friction multiplied by 30 cos 60, making the coefficient of friction 10.98 divided by 30 cos 60. The coefficient of friction is 0.73. 2 is equals to mu. So we can write it down. The coefficient of friction is equals to 0.732. So this is part B. The force of magnitude 15 Newton is now replaced by a force of magnitude x Newton acting up the line of greatest slope. Find the greatest value of x for which the block does not move. So again, since the block is not moving, the acceleration is 0, and we can use the forces formula again, since we will assume that the other forces acting on the block are the same except for the x Newton force. So I'll be making the diagram again. So it's inclined at 60 degrees, and when we resolve the weight, and this is the x Newton force. So they've asked us for the greatest value of x. Now when we write down the forces formula, we can tell that the greatest value of x will only be in the case when friction acts against that force. Because see, if you write it like this, forward force will be this x Newton force, and the resistive force can be the friction plus the horizontal component of the weight, since they're now both acting in the same direction, downwards. Minus 30 sine 60 is equals to 0. I've applied the forces formula here. So mass multiplied by 0, which is the acceleration, will make this side 0. So that means that x is equals to friction plus 30 sine 60. This will give us the highest value of x. If friction was acting opposite or with the force of x, this would be written as x plus friction minus 30 sine 60 is equals to 0, which would make it that x is equals to 30 sine 60 minus friction. This will give the lowest value of x. So this means since we want the greatest value of x, we will use this equation. So from the last part, we know that friction was equals to 10.98. Since the coefficient of friction and the value of r is the same, so x is equals to 30 sine 60 plus 10.98 which is 36.96. We can round it off to 3 significant figures, which makes it 37 newtons. So the greatest value of x is 37 newtons. This is question number 4. So it says 2 blocks A and B of masses 4 kg and 5 kg respectively are joined by light inextensible string. The blocks rest on a smooth plane inclined at an angle of alpha to the horizontal, where tan alpha is equal to 7/24. The string is parallel to a line of greatest slope of the plane with B above A. A force of magnitude 36 Newton acts on B, parallel to a line of greatest slope of the plane. Find the acceleration of the blocks and the tension in the string. So first, talking about this introductory paragraph that they've given us. First, they've given us the masses of both the blocks, so we need to resolve the weights. So for block B, there will be a downward pressure of the weight, and so the angle over here will always equal be to the angle over here. We can write this as 50 cos alpha and 50 sin alpha. And for block A, when we resolve the weight, this will become 40 cos alpha and this will become 40 sin alpha. This way. And then what they've given us is that they are at rest on a smooth plane. Rest means that the initial velocity is 0 and the smooth plane indicates that there is no friction. Then they've given us the value of tan alpha. Now in this question you will need to be using the value of sin alpha and cos alpha. Now we can use the rules of trigonometry to find out the exact value, the exact numerical value in fractions of both cos alpha and sin alpha. For example, this is the triangle and this is the angle alpha. So tan is always equals to the perpendicular, which is 7, over the base, which is 24 in this case. So now we can use the rules. Now we can use the Pythagoras theorem and find out this side. So 24 squared plus 7 squared. So this side is 25. So that means that sin alpha is equal to the perpendicular over the hypotenuse, so it's 7/25, and cos alpha is equal to the base over the hypotenuse, which is 24/25. So now we have the exact values of sin alpha and cos alpha, and so we know that there is a force of 36 Newton. So this is a horizontal, it's parallel to the line of greatest slope, so we do not need to resolve this. So we need to find the acceleration of the blocks and the tension in the string. We cannot find this out using the formulas of kinematics, such as V is equals to U plus AT or V square minus U square is equals to 2AX, because there's a lot of unknown information that we do not know. In that case, one simple formula that we use is the forces formula, which is that forward force minus resistive force is equals to MA. Now, another important thing to realize is that they're joined by a string. So that means there will be tension in the string. This way. So for block B, the tension in the string will be a resistive force, as it will be pulling it down. However, for block A, it will be the forward force because it will be pulling it upward. So let's write it in terms for particle B. So for particle B, the forward force is the 36 Newton force, which is acting exactly on the block B. so that will be 36, and the resistive forces will be the horizontal component of the weight as well as the tension in the string. So this will be minus tension in the string minus 50 sine alpha is equals to the mass, which is 5, multiplied by the acceleration. For particle A, the same tension of the same magnitude acting on B will be the forward force, while the resistive force will be the horizontal component of the weight, which is 40 sine alpha is equals to the mass multiplied by the acceleration. Now we can simultaneously solve this. So there's minus t over here and plus t over here, so you can cancel those out. So that means that 36 minus 50 sine alpha minus 40 sine alpha is equals to 9 multiplied by the acceleration. So we have the value of sine alpha, which is 7 over 25, and we can plug it into the equation, and then we can rearrange it to find the acceleration. So this will become 36 minus 10.8 is equals to 9 times the acceleration, 1.2. Now we can substitute this value of the acceleration into any of these two equations, and we can find the tension in the string. So I'll use the equation of particle A. T minus 47 sine alpha is equals to 4 times 1.2. Tension is equals to 4 times the acceleration plus 40 times 7 over 25, which is 16 newtons. So now we have the value of both the tension in the string and the acceleration. So we can make a statement over here, which is acceleration is equals to 1.2 meters per second square, and tension in the string is equals to 16 newtons. That's part A. Part 2 states, at a particular instant the speed of the blocks is 1 meter per second. Find the time after the instant that it takes for the block to travel 0.65 meters. So let's write down the information that they've given us. So the initial speed is 1 and the distance traveled is 0.65 meters. So now, since there's mention of speed and distance, means that now we can use the formulas of kinematics, which we can write them down on the side to see which one is the most appropriate for the information we have. So we have v is equals to u plus at, we have v square minus u square is equals to 2ax, and then we have x is equals to ut plus half at square. So we need the time, and in the previous part we found out the acceleration of the blocks. So the acceleration was 1.2. So we can see that the third formula is the most appropriate, since we have the acceleration, the distance traveled, as well as the initial speed. So that means that 0.65 is equals to 1t plus half times 1.2 t squared. So 0.65 is equals to t plus 0.6 t squared. So we can rearrange it and write it as this. Multiply both sides by 100. So and we can solve it by applying the quadratic equation. 0.5. Let's find out the other value just in case. So it's -2, so we'll not write it. So T is equals to 0.5. A small ring P is threaded on a fixed smooth horizontal rod AB. Three horizontal forces of magnitudes 4.5 Newton, 7.5 Newton and F Newton act on P. Given that these three forces are in equilibrium, find the values of F and theta. So before we do this, we need to resolve these three forces. So this, since it's acting in this direction, we'll have F sine theta, F cos theta. This will become 4.5 cos 20 and this will become 4.5 sine 20 in this direction. And for 7.5, it would also move leftwards, which is 7.5 cos 20, and this, and the component of the 7.5 Newton force, which is acting downwards, will be 7.5 sine 60. Sorry, this is 60. So let's read the question, the important parts of the question. So since it is a smooth rod, so there is no friction at all. And the other important key information that they've given us is that the three forces are in equilibrium. So and you might ask that why aren't we resolving the weight of the ring? The question states that it is a small ring. So that means that its weight is so small that it would not affect the state of equilibrium. When we're talking about equilibrium, we know that the forces acting rightwards must equal to the forces acting leftwards. So first let's write this down. So that means that F cos theta is equals to 4.5 cos 20 plus 7.5 cos 60. And then we also know that there must also be equilibrium vertically, which means that forces acting upwards must equal to the forces acting downwards. That means that F sine theta plus 4.5 sine 20 is equals to 7.5 sine 60. Now, the two missing variables are F and theta, which means that we will need to use simultaneous equations. Now, one foolproof way that I always use and I have used in my exams is to make both of the equations in terms of cos theta. One equation needs to be in the form of cos theta and one equation needs to be in the form of sine theta. So this equation is already equal to F cos theta, so we need to make this equal to F sine theta. So F sine theta is equals to 7.5 sine 60, and then we'll take this on the other side, minus 4.5 sine 20. Now we can apply the rules of trigonometry. So we all know that sine theta divided by cos theta is equals to tan theta. So if we write F sine theta over F cos theta, the F's in the numerator and denominator will cancel out, and sine theta divided by cos theta is equals to tan theta. And we can express F cos theta and F sine theta as numerical values. So let's calculate this first. So F cos theta is equals to 4.5 cos 20 plus 7.5 cos 60, which is equals to 7.98. Let's round it off. And then so F sine theta is this, so let's calculate this. So it will be 7.5 sine 60 minus 4.5 sine 20, which is 4.96. So sine theta over cos, so tan theta will equal to sine theta 4.96 over 7.98. And then we can apply inverse tan. So theta is 31.8 degrees. Now we can use this value of theta and substitute it in any of these two equations. I'll just choose this one. So f cos theta is equals to 7.98 as we calculated over here. So that means that f cos 31.8 is equals to 7.98. So we divided both sides by 31.8. We know that f is equals to 7.98 divided by 31.8, which is, it's divided by cos 31.8, my bad. So 7.98 divided by cos 31.9, which is 9.39. So we can write it as 9.4 newtons. Then we can write and present our answers in the end. So theta is equals to 31.8 degrees and f is equals to 9.4 newtons. Part 2. It is given instead that the values of f and theta are 9.5 and 30 respectively, and the acceleration of the ring is 1.5 meter per second. Find the mass of the ring. So this means, so they've given us the acceleration, which is 1.5. So that means that this ring is moving this way. See? So we can use the forces formula, which is forward force minus resistive force is equals to ma. So that means the forward forces will be the forces that is moving them rightwards, and the resistive forces will be those forces which is moving it leftwards. So that will mean that f cos theta minus 4.5 cos 20 minus 7.5 cos 60 is equals to the mass multiplied by the acceleration which they have given. So we can write this as f cos theta minus 4.5 cos 20 minus 7.5 cos 60 is equals to the mass which we have to find times 1.5, which is the acceleration. So, and they've given us the value of f and theta, so we can write it like 9.5 cos 30. So 9.5 cos 30 minus 4.5 cos 20 minus 7.5 cos 60 is 0.249 is equals to 1.5 m. So the mass must be equal to 0.249 divided by 1.5, which is 0.166. So we can write the mass of the ring is equal to 0.166 kg. Question number 6. A particle of mass 0.4 kg is released from rest at a height of 1.8 meters above the surface of the water in a tank. There is no instantaneous change of speed when the particle enters the water. The water exerts an upward force of 5.6 newtons on the particle when it is in the water. Find the velocity of the particle at the instant when it reaches the surface of the water. So first we should make a diagram to represent the situation because we have a lot of information. So the first thing is mass is equals to 0.4, and since it is released from rest, it means that initial velocity is 0, and so let's assume this is 1.8 meters and the particle will obviously be released from this point, and this is the tank of water, and there's an upward force of 5.6 Newton on the particle. So basically what they're saying is that this is the resistive force that is acting in the water, which will prevent the particle from moving downwards. So this is 5.6 Newton. This is the resistive force. So part 1 just asks us that find the velocity of the particle at the instant when it reaches the surface of the water. So initial velocity is 0. We need the final velocity, and since it is still above the surface of water, the force of gravity is acting with it, so the acceleration will be positive 10, and there is this 1.8 meters needs to be covered, so the distance traveled needs to be 1.8 meters. Kinematics usually uses 3 formulas. One is V is equals to U plus AT. Second is V square minus U square is equals to AX. And the third is X is equals to UT plus half AT square. Now seeing the information that we have over here, the second formula is the most efficient way to solve it. So when we add this information, this will become, so we can find out the final velocity. See, pretty easy. This was pretty straightforward. So V square is 36, so the final speed will become 6. Part B, find the time that it takes from the instant when the particle enters the water until it comes to instantaneous rest in the water. You may assume that the tank is deep enough so that the particle does not reach the bottom of the tank. So they're saying that the particle comes to instantaneous rest in the water, so we know that the final velocity is 0. And so in the first part we found out the speed of the particle when it reaches the surface of the water. So, and they've also given us another key information, which is that there is no instantaneous change of speed when the particle enters the water. What the examiner is trying to tell you is that the speed at which the particle is operating at this point will be the same speed that it will have when it hits the surface of the water. So that means that this speed is the initial speed in this question. Now we can also use these formulas again in this part. So in this we have to find out the time. So the time is the missing variable. So we can use this formula if we have acceleration, which is V is equals to U plus AT. And so we can find out acceleration using the forces formula, which is that forward force minus resistive force is equals to the mass multiplied by the acceleration. So the forward force will obviously be the particle's weight. So that will be 0.4 times 10. 4 minus, and since the question has mentioned that the resistive force is 5.6 newtons, so this will be minus 5.6 is equals to the mass of the particle multiplied by the acceleration. So, and then we divide this by 0.4. So the acceleration is minus 4, which is true and logical, since as the particle will be moving down in the water, the speed of it will slow down. So now we can use this formula. The final speed, since it comes to instantaneous rest, is 0, and the initial speed was 6. So 6 is equals to 4t. So t will be 6 divided by 4, which is 1.5. and you can write this down at the end as it takes 1.5 seconds for the particle to reach instantaneous rest. Now, this question was pretty straightforward, but usually sometimes the examiner will try to trick you by adding more, by changing the wording of the question. Now, in this question, they said to find the time that it takes from the instant when the particle enters the water. So sometimes they can trick you by asking you to find the total time until the particle reaches instantaneous rest. If they had asked for the total time from projection, which means from the time that it was released till the point that it comes to instantaneous rest in the water, you would have also found out the time that it takes for it to start from this point and reach this point, and then you would have added 1.5. So for part 3, you need to make a velocity time graph for the particle from the instant at which it is released until it comes to instantaneous rest in the water. So for this, you will need to analyze information given to you and also the information that you have gathered. And in order to make a graph, you will need 3 points. One will need to be the starting point of the journey. The third point needs to be the velocity and time at the end of the journey, and then you also need a point in the middle of the journey. This is because the journey from the instant at which it is released until it comes to instantaneous rest is in 2 parts. So since this is evident to you since there are 2 different accelerations. We all know that the gradient of lines in a velocity time graph is acceleration. So we found out that when so this is the particle, this is the 1.8 meters from which it was released, and this is a tank of water. So we found out that since it's still in the air, the acceleration was 10. So that means from this point till it reaches the surface of the water, there will be one upward sloping straight line. But then we also found out that in the first part that the final velocity over here at this point was 6. And then we know that from this point until it comes to rest in the water, which means final velocity is 0, the acceleration from this point to this point was -4. That means there will be another downward sloping line. So let's find out the coordinates. So since it was released from rest, we know that when time is 0, velocity is also 0. In part 1 of this question, we found out that the final velocity of the particle is 6 when it reaches the surface of the water. So we need to find out the total time it took from this point until the particle reaches the surface of the water. So we have the initial velocity, which is 0, the final velocity, which is 6, and the acceleration, which is 10 due to gravity. So we can use this formula, v is equals to u plus at, and you plug in the information. So it takes 0.6 seconds. So since it is continuous movement, the journey of the particle is a continuous movement. So that means that the total time will be taken, which is 1.5 plus 0.6, which is 2.1, and the final velocity was 0. So now we have 3 pairs. So now we have 3 coordinates and pairs of velocity and time, which is 0 and 0, 0.6 and 6, and 2.1 and 0. We can now graph this. We need to get a scale and measure. So I am taking 2 units on this axis, and then I'm taking 3 units. So label your graph. So the x-axis will be time and the y-axis will be velocity. So when t is equals to 0, velocity is 0. You can mark your points. So we have time over here, so we can use increments of 0.7. So that means this will be 0.7, this will be 1.4, and then this will be 2.1. Let's extend this a little bit to make it more neat. And so at 0.6 we have velocity is 6. So 0.6 will be about here, close to 0.7. So we can make 1 inch over here, 3, and this becomes 6. At 0.6 the velocity is 6, and then at 2.1 velocity is 0 again. Now we can join these 3 points. These are two straight line segments. This point to this point is from release till the surface of the water, and this is from the surface of the water till it comes to rest in the tank of water. On to question number 7. A particle moves in a straight line starting from rest at O and comes to instantaneous rest at P. The velocity of the particle at time t seconds after leaving O is v meters per second, where v is equals to 0.6 t squared minus 0.12 t cube. Showed that the distance OP is 6.25 meters. So first let's draw a diagram showing the situation. So the starting point is point O, and then it comes to instantaneous rest at point P. So our initial velocity is 0 and our final velocity is also 0. And they're telling us to find us this distance. In this case, distance is equal to displacement. So they've given us the equation for velocity. First, we need to find out the time at which velocity is 0. So for that, we will equate velocity to 0. So 0 is equals to 0.6 t square minus 0.12 t cube. So first let's make these whole numbers. So I'll multiply it by this whole, both sides by 100. So 0 is equals to 60 t square minus 12 t cube. Now we can simplify this further by dividing both these numbers, both sides by 12, sorry. So this will become 5t square minus t cube. So we'll take t outside, so this will mean that 5t minus t square is equals to 0, which means t is equals to 0, or 5t minus t square is 0. So let's solve this further. 5 minus t is equals to 0, so t is equals to 5. T is equals to 5 or t is equals to 0. This corroborates with the question, since velocity is also equal to 0 when starting from point O. So when time is 0, velocity is 0. So this is true. And at another point, when 5 seconds have passed, velocity is equals to 0 again. So this means that the particle reaches point P after 5 seconds. Now, in order to find the distance, we need to find out the displacement of the particle after 5 seconds. So we know that displacement is we can find the equation for displacement when we integrate velocity. And the limits will be 5 and 0. Since we need the displacement for 5 seconds, for the first 5 seconds. So this will be and when we integrate this, we'll have 0.6 t cube divided by 3 minus 0.12 t raised to power 4 divided by 4. So this will become 0.2 t cube minus 0.03 raised to power 4. And now when we plug in the values of 5 and 0, we will come with 6.25. I've only plugged in the value of 5 since we know that whenever we'll plug in 0, the answer will just become 0. So when we plug in 5, we get 6.25. And so we have proved that the distance OP is 6.25 meters. So we will just give a final statement at the end of the question. The distance OP is equals to 6.25 meters, and then in the bracket we'll write shown. Part B. On another occasion, the particle also moves in the same straight line. On this occasion, the displacement of the particle at time t seconds after leaving O is s meters, where s is equals to this equation. It is given that the particle passes point P with velocity 1.25 at time t is equals to 5. Find the values of the constants K and C. So when you will go through the other past papers, you will learn that there is a pattern. Whenever you have two missing constants, you will always be asked to make two simultaneous equations. For that, you will need to carefully look at all the parts of the question and also the additional information that are given to you. Now, in this part, they have given us that when t is equals to 5, your velocity is equals to 1.25. And then from the previous part, we also now know that the distance OP is equals to 6.25. Which means the displacement of P when time is equals to 5 is 6.25. So since we have the equation of displacement given to us, first we'll solve that. So displacement must be 6.25 and t is equals to 5. Now let's simplify this. So 6.25 is equals to 125k plus 3125c. And then in this part, we know that t is equal to 5 and velocity is 1.25. And we all know that when we differentiate displacement, we get velocity. So when we differentiate this, we will get 3k t square plus 5c t raised to power 4. Since k and c are constants, we will multiply it. This will not go away. The constants will not go away. So in place of velocity, we will add 1.25, and then for time we will add 5. So 1.25 is equals to 3 times 5 raised to power 2, 75k plus, so we have 5, another 5 here, so this will become 5 raised to power 5 plus 3125c. So this is one equation and this is the other equation. You can see that 3125 and 3125c is present in both equations. So we can use any one equation and make it in terms of k and this value, or so basically we can write this as 6.25 minus 125k is equals to 3125c. And now we can substitute this value in place of this, in place of 3125c. So this will become 1.25 is equals to 75k plus 6.25 minus 125k. So 75 minus 1.25 minus 125, sorry, is minus 50k, and 6.25 will go to the other side and get subtracted. So it's 1.25 minus 6.25. So this is minus 5. We divide by minus 50 on both sides and we get k is equals to 5 over 50 or 1 over 10. So this will become 0.1. Now we can substitute this value of k back in this equation and we can find out the value of the constant c. So 6.25 minus 125 times 0.1 is equals to 3125c. So c is equals to 6.25 minus 125 times 0.1, and then you need to divide it by 3125. So it's 0.002. Yes. So we write the final statement. Hence k is equals to 0.1 and c is equal to 0.002. Now part 3. Find the acceleration of the particle at time t is equals to 5. So we all know that when we differentiate velocity we get acceleration. So we found out the equation for velocity over here. So now we have the values of k and c, so we will need to plug in those values to find out the equation of acceleration. So acceleration is equals to 3 times 0.1 t square plus 5 times 0.002 t raised to power 4. And sorry, this is velocity, my bad. So this will become 0.3 t square plus minus 0.01 t4. So when we differentiate this, acceleration will become 0.6 t minus 0.04 t cube, and we will add 5, substitute 5 in place of t, and we will get 0.6 times 5 minus 0.04 5 cube minus 2. So we can write this as acceleration is equals to minus 2 when t is equals to 5. That is the end of question number 7 and this paper.